This video is about multiplying and dividing rational expressions. We're actually going to start by just learning how to simplify a rational expression. So you know by now that a rational expression means it's got a fraction with x on the numerator and the denominator, or sometimes just in the denominator. To simplify these, as I've told you before, you're not going to be able to just cancel out these x squareds, okay? That does not work, not when there is addition or subtraction involved in either the top or the bottom. What you need to be able to do here is factor and cancel out an entire factor. If you can do that, then you can reduce the fraction or simplify the fraction. So the numerator of this is going to factor to x minus 5, x plus 3. And the denominator is going to factor to x plus 3, x minus 3. This is why we practice factoring so much. It never goes away. Now we have an entire factor, the x plus 3 that appears in the numerator and the denominator, that can cancel out, leaving us with x minus 5 in the numerator and x minus 3 in the denominator. And that's the simplified version of the original problem. Let's try the next one here. It's a different type of factoring, but we can still factor the numerator. We can take out a 20. You have to show the 20 that you're taking out, which will leave us with 2x plus 1 inside, over. In the denominator, we can take out a 10, which will leave us with x plus 3. Now, the 2x plus 1 and the x plus 3 aren't identical, so we can't cancel those out at all. But the 20 over the 10 can be reduced, just like any other fraction, right? We can simplify 20 over 10, make it 2 over 1. So this becomes 2 times 2x plus 1 over, I don't need to show the 1, so I'll just show the x plus 3. And you can leave your answer like that. Students often ask if you have to distribute that 2 back in on the top. In fact, no, it's better to leave it in factor form in your final answer. That's more simplified. Now we get into multiplication. So what if I have two rational expressions, two fractions with a multiplication sign between them? Well, just like the fraction 2/3 being multiplied by 4/5, when you multiply fractions, you just go straight across the top to get 8 and straight across the bottom to get 15. And then you see if you can simplify your final answer, which here you wouldn't be able to do. I'm going to erase this example and try the one that's up there, which has variables in it. If I can go straight across the top and combine these two fractions, then the numerator is going to be 8 times 7, which is 56. I have x to the third and an x to the fourth, which is going to become x to the seventh. Then I have y and y to the third, which will become y to the fourth. Then I hop to the denominator. I have a 2 times a 4, which is 8. Then I have x. He doesn't have anything to combine with, so he just stays there. And then y to the second and a single y becomes y to the third. And like I said, you have to check your final fraction and see if you can simplify this, which of course we can. The 56 and the 8 will just become a 7 on the top and a 1 on the bottom, which I don't need to show. We have x to the 7th over x, which is like having x, 7 times on top and once on bottom, so that one of them is going to cancel out. We'll be left with x to the 6th on top. Then we have y to the 4th on top and y to the 3rd on bottom, which is a single y on top. In fact, I don't even need this fraction mark because the fraction has gone away. Let's make that look more like a y. And that's it. That's the product of those two original fractions. Okay? Now we have two rational expressions, two fractions, multiplication sign between them. But each one of them is like a polynomial that you can factor. So these have plus and minus signs, which, to go back a second to the slide we just did, these didn't have any addition or subtraction signs in them, so we just went straight ahead and combined them. In this one, with the addition and subtraction there, I would like to see if I could factor first, then I'll worry about getting these together. Okay, so my first fraction I have on the numerator, I can definitely take out a 3x, I have to show it. I'll be left with 1 minus x. In the denominator, I have x, let's say, plus 5 and minus 1, okay? And then in the other fraction, keep the multiplication sign there for now. On the top, I will have x plus 5 and x minus 4. And on the bottom, there's nothing I can do with that 3x, so I will leave it. Okay. Now, because this is multiplication, and I'm going to go straight across the top and then straight across the bottom, what I like to do is just erase the multiplication sign and make it one big fraction, right? This is how I would multiply these two fractions together. I would put all of those things on the top and all of those factors on the bottom. Now look for things that can cancel out. I can cancel out this x plus 5 with this x plus 5. I can cancel out this 3x with this 3x. And now I'm a little stuck on this 1 minus x and x minus 1. It's like I want them to be the same thing, but they're not really the same thing. So I wonder if there's something I can do to make the top identical to the bottom so that I can cancel them out. I'll rewrite now what I have. I have this, I have x minus 4 still, and on the bottom I have x minus 1. So what I was saying was I want to be able to rewrite this so that it matches what it says on the bottom. The way I'm going to do that is by taking out a negative 1 from it. By taking out a negative 1 from a 1 minus x, okay, I show the negative 1 that I'm taking out. The 1 will become a negative 1, right? It's division when you take something out. And the x will become a positive x. Take a minute and digest that. We took out a negative 1, which changes both of the signs inside. Okay? Now what we have actually matches what we have on the bottom. Because that negative 1 plus x is the same as saying x take away 1. Which means I can now cancel this x minus 1 with this x minus 1. But you have to show the negative 1 that you took out because it's part of your answer now. So my answer is going to be negative 1 times x minus 4. And there is nothing left in the denominator. Now you only have to use this trick when you have subtraction where one of them is backwards. If you're ever trying to cancel out like 3 minus x and an x minus 3, that's when you would take out the negative 1. Okay, you don't have to do it that often, but you do have to do it if you're trying to reduce two subtraction problems that are inverted. Okay. This is the same kind of thing, only the second fraction is not written as a fraction, but we can put it over 1 so that we can use the same principles that we just used. Let's factor first. So this is going to be x plus 2. Can't factor that. And on the denominator, we have the Stokes formula, the difference of cubes. So we'll have x minus 3, because 3 times 3 times 3 is 27. And then in the other parentheses, it's x squared plus 3x plus 9. Right, same, opposite, always positive. Sorry, that fraction bar got a little wiggly. And I'm going to multiply that by, on the numerator we'll have, how does that factor? Guess that doesn't factor, so we're going to have to leave it as x squared plus 3x plus 9. And on the denominator we have a 1. Now like I said, when I multiply fractions together, I'm just going to go straight across the top and straight across the bottom. So I'm going to connect it, make it one fraction, and look for things that can cancel out. This entire factor goes away. The 1 doesn't matter. So I'm left with x plus 2 over x minus 3. That's as simple as it can get. Then we move on to division. Division with any fraction, I'll show you with the just numbers. If you're dividing 2/3 divided by 4/5, the rule that you were taught back in elementary school was change it to multiplication and flip the second fraction, right? Keep, flip, change, some teachers will call it. So we change it to multiplication and we flip the second fraction. And then it works like a multiplication problem. You go straight across the top and straight across the bottom. And then you see if you can reduce your final answer or simplify your final answer. And that's basically the same thing that we're going to do with the x. We're going to factor and flip the second fraction. I like to do this in one step. So the first fraction doesn't change. I can factor the bottom. I'm going to change it to multiplication now. And I'm going to flip this fraction, okay? So the x squared minus 11x plus 30 is going to come up to the top. And when I factor that, it's x minus 6, x minus 5. And then the x squared minus 6x comes to the bottom. And when I factor that, it's x. I'm taking out an x. I'm left with x minus 6. Now it's multiplication, so I can just erase my multiplication sign and write it as a single fraction. And then look for factors that cancel out. This cancels out with this. This cancels out with this. I'm left with 7x over 2x. And these x's, because there's no addition or subtraction here, I can cancel them out. And my final answer is actually just 7 over 2. And that's the simplified version of that division problem. And that is it.